Okay, for this one it reads, do people walk faster in the airport when they are departing, getting on a plane, or walk faster when they are arriving, getting off a plane? A reputable researcher measured the walking speed of random travelers in 2 international airports. His findings are summarized in the table. Let's look at this table. Okay, so we have the mean speed when they depart versus the arrival, and standard deviation and the sample size for each. So is this an observational study or designed experiment? So we haven't talked a lot about this in a while, right? It hasn't been probably since chapter 1 or so. So are they imposing some sort of variable on them? Are they just sort of watching what's happening? Are they imposing some sort of treatment? No, they're just sort of watching what's happening, right? So this is an observational study since the researcher did not influence the data. Okay, explain why it is reasonable to use Welch's t-test. Now, Welch's t-test is just another name for the t-test. We have rather large samples. Remember what needs to happen is we have to have large samples, or they need to be normally distributed. We're not given that they're normally distributed, but they are rather large. When I say rather large, that's sort of relative, right? Anything bigger than 30, and they both need to be bigger than 30, and in fact, they're both 35. And the samples are obtained using a simple random sample, and it appears that they are, where it says that a reputable researcher measured the walking speed of random travelers. They didn't look at just everybody getting off one plane. Maybe that plane was really late and they were trying to book it to another flight. So we're assuming that they did a random sample of this. And the sample can't be too big either. And we haven't talked a lot about that, but it can't be more than 5% of the overall population. So random, large, and independent. Sorry, I marked the wrong one. And independent. Okay, now do individuals walk at different speeds depending upon whether they are departing or arriving? So we're at the 0.05 level of significance. So mu1 represents the mean speed of people departing. Mu2, the mean speed of people arriving. So it'd be nice if this was like mu-d, right? Although mu-d, that could be confused with difference. I guess I can see why they did that. It represents the mean people arriving. So state the null and alternative hypothesis. So remember, it just says, do people walk at different speeds? It doesn't have a sense of one will be faster than the other. So we're going to choose C, where the null is always equals. And then the alternative, in this case, since it's different, is not equal to. Now determine the p-value. So now we're going to put these values into StatCrunch. And we've already done several problems like this. I'm going to let you do that. I wanted to kind of hit these first two, which we haven't done a whole lot about, and I wanted to also reemphasize the null and alternative hypothesis and sort of the keywords to look for on those. So remember, if you get a low p-value, and how low is too low? In this case, anything below 0.05. So if our p-value is below 0.05, we reject HO, that they are, in this case, that they're equal, and conclude that they're different. And what we'll often do, I don't think this problem will ask it, but if there is a difference, I would run a complex interval. What is that difference? Okay? It doesn't ask that in this particular problem, but just know that is often the case. And so I hope that helps.